Welcome to my video again. Today we'll be looking at dot products. In our last video, we defined vectors and scalars and looked at some examples. So today we'll be looking at dot product. We define a dot product and then look at examples. Now, I've defined dot product of two vectors, and you remember that we said that a vector A or another vector will be represented by A with an arrow above it and vector B with an arrow above it. So if we have two vectors A and B, then in our last class we said that their magnitude of A will be denoted by this, and the magnitude of B will also be denoted by this. So these are just vertical lines, and so this means magnitude of A, magnitude of B. So what is dot product or scalar product? They mean the same thing. Dot product or scalar product of two vectors A and B is just the product of their magnitudes and the cosine of the angle between them. That means if you have those two vectors here, these two vectors, so, and this is the angle between them, call it theta. Just draw it clearly. So suppose we have this vector A and this vector B. Let me just show that they're pointing in the other direction. And suppose that this is the angle between them. So what is the dot product of this? And we are saying that the dot product will be the product of the magnitude of A and the magnitude of B and the cosine of the angle between them. So this is A dot B, dot product, A dot B. A dot B would be the product of their magnitudes and the cosine of the angle between them. So that's what I've said. And so from even the word, from the name, the dot product is a scalar and not a vector. It's a scalar and not a vector. And you remember those two terms, we defined them and gave the difference in our last video. So this is the definition of the dot product between A and B, and theta is the angle between them. So again, as I've already stated, the dot product is right? The dot product is a scalar quantity and not a vector quantity. Now, so this formula is very important to us because one, apart from giving us the dot product, we can also use the same formula to get the angle between any two vectors. Because if you want to get the angle between any two vectors, then you just make cos theta the subject. Cos theta the subject of the formula, and you have that A dot B over the magnitude of A times the magnitude of B gives equals theta. So that theta is cos inverse of this. Cos inverse of this. Now what will happen if theta were to be 90? If theta is 90, then you know that cos 90 is 0. So that means that when theta is 90, then A dot B will equal to 0. And that means that these two vectors are perpendicular to each other, are perpendicular or orthogonal. So we can tell if vectors are perpendicular to each other by finding their dot product. So that if their dot product is 0, then we'll say that the two are orthogonal to each other. What about if they are parallel? When do we say that vectors are parallel? What is the angle between two vectors which are parallel? That is the question. Because we know the formula for getting for A dot product, because we know that A dot B from our previous A dot B is the modulus or the magnitude of A times the magnitude of B cos theta. And what I know is that two vectors are parallel if the angle between them is 0. That is, if they are pointing in the same direction, or if the angle between them is 180, if they are pointing in the opposite direction. So what will happen if theta is 0? If theta is 0, cos 0 is 1. So that means A dot B will equal to the magnitude of A times the magnitude of B. What about if they're pointing in the opposite direction? That is, the angle between them is 180. Cos 180 is negative 1. So we would have A dot B equals negative magnitude of A times magnitude of B. So if this happens, then we know that the two vectors are parallel to each other and they point in opposite direction. And when this one happens, it means they're parallel to each other, but they point in the same direction. And therefore, what this means is that the dot product is very important to us because it can help us to tell if vectors are orthogonal, parallel, or not, or neither orthogonal nor parallel. So you can tell if they're parallel, orthogonal, or not. You may just do that by even finding the angle between them. Find the angle between them and tell the angle is 90, the angle is 180, the angle is that. Or just find the dot product and see, because if it's 90, the dot product will be 0. If it's parallel and it's pointing the same direction, the dot product will be equal to this. And if they're pointing in the opposite direction, the dot product will be equal to this. So you can also just use this to determine if they're parallel, orthogonal, or neither. So let's look at this example. The example says, are the following vectors orthogonal, parallel, or neither orthogonal or parallel? So in other words, just find the dot product and see. And you can also find the magnitudes and then relate. So let's do the first one. Let's find the dot product of the first one. How do you find the dot product? The dot product, let me show you how we find it. Dot product, we just multiply this times this plus this plus this one times this. But I'll be showing you how to multiply I times I, what you get. I'll be showing you that in the next video. But today, just multiply the coefficients. Just multiply the coefficients. So the dot product of A and B, A dot B, would be just be 2 times 4, which is 8, plus 3 times negative 2, which is negative 6, plus 1 times negative 2, which is negative 2. And you can see this is 0. So that means these two vectors here are orthogonal, or they're perpendicular to each other. So as I've told you that for us to get the dot product today, let's just multiply the coefficients, the respective coefficients. The one of i's, multiply them. The one of j's, multiply them. The one of k's, multiply them. And in the next video, I'll show you how to what I times I will give us. No, I dot I. What I dot I will give us. What j dot I will give us in the next video. Now, what about this? So we've said that this is orthogonal. These two are orthogonal. What about this one? Let's find the dot product. This will be 8 minus 18 plus 3. What is this? This is negative 10, which is negative 7. So they are not orthogonal. These two are not orthogonal. So we need to find if they are parallel to each other. So to find if they are parallel, let's find the magnitude of P. The magnitude of P. 2 square is 4. 6 square is 36. And 3 square is 9. So this is 49, which is 7. What about the magnitude of Q? The magnitude of Q is 4 square, which is 16, plus 3 square, which is 9, plus 1 square. So this is 10, 26. Now, so I found P dot Q to be 7, to be negative 7, to be negative 7. What about the product of their magnitudes? What will that give us? This will be 7 with 26. So there's no relationship between this dot product and the product of their magnitude. And therefore it means, again, these vectors are not parallel. And that's what I see. That's what I did. That's what I did last time. What I did was I found the dot product and it was 7. Actually, it's supposed to be negative 7. It's supposed to be negative 7 because this is negative 10. It's supposed to be negative 7. Hence, the two vectors are not orthogonal. So we determined if they're parallel, and we found that the product of their magnitude is that. And that means that they are also not parallel. It means they are also not parallel because we've not found any of these two conditions satisfied. For them to be parallel, it must be either this condition or this other condition. None of them is satisfied, so they're not parallel. Okay, let's look at this other example. Want to see if it's orthogonal or parallel or neither. So let's begin with the m dot n, and this is 2 times that, which is 12, 7 times that, which is 147. In fact, and then negative 7 times that, which is positive 147. This is positive. This is also positive. Yeah, that's positive. So I did this. Let me see what we got. What I got, that we can move fast. I got 3 or 6 when you add those 3. When you add those 3, you get 3 or 6, which is not equal to 0. That means the vectors are not orthogonal. So now I also computed their magnitude and found that the magnitude of m was this and that of n would be this. So the two together gives me 3 or 6. And since this equals the product of their magnitude, it means these two vectors are parallel. In fact, they point in the same direction. Let's look at the last example. Here. Find the value of n so that find the value of n so that this vector is perpendicular to this. This one is very easy. Just get the dot product and equate to 0. So the dot product, this times this, gives me 5n square, and this times this gives me negative 15n, and then this times this gives me 10. For them to be orthogonal, then this dot product should be equal to 0. This dot product A dot B, which equals this, must be equal to 0 if they to be orthogonal. So you solve this equation quadratically, or you can factorize if it can be factorized. But the thing is, find the value of n. So whichever method you choose, whether it's factorization or quadratic formula, then you must get the n. So I used to go factorization, and I found that n will be 1 or 2. So if n is 1 or 2, then those two vectors would be orthogonal. So that is okay. So as I already mentioned, we can get the angle between vectors, and we use this formula. So that one is very easy. So for example, find the angle between these two. So the thing is, just find the dot product and then find the magnitudes and make theta the subject of the formula. So let me just do that very fast. So A dot B is 1 times negative 2, which is negative 2. And then negative 2 times negative 6, which is 12. And then 2 times negative 3, which is negative 6. And this gives you 4. That gives you 4. Then what about the magnitude of this vector? The magnitude of this vector is this: 1 square plus 4 square plus 2 square. 1 square plus 2 square plus 2 square, which is 3, the square root of that. And then again, the square root of this gives us the magnitude of this other one. So the magnitude of the vectors are 3 and 7 respectively. And their dot product is 4. So what about cos theta? Cos theta will be 4 over the product of the magnitudes. And finding theta, you find cos inverse of this, which gives you approximately this angle. So that is the angle between these two vectors. So next time we look at the dot product of unity vectors I, j, and k. So that's what we'll be looking at in our next video, the dot product of unity vectors I, j, and k.